If you are visiting our channel for the first time, please subscribe first to get the latest updates. Today we are going to start a very important concept of limits in functions. We are going to have a series of lectures on the limits, how you can find the limits, what is the concept of limits in functions, and how you can evaluate the limits by using on different kinds of functions. But today we are going to start the introduction of limits, that what they are actually. So before evaluating the limits or have the of further concepts of limits, first we will see what the limits actually are. What is their purpose of introduction in the mathematics? So if you look at the statement, that is, sometimes we prefer reaching near to destination rather than on it. This statement has a very deep meaning. How? For example, if you are going like this on a plane, and you are going and going and going like this, but what if you reach what if you reach at this point? If you reach at this point, you will probably fall down. So it means you will not prefer to reach this destination or this end point. Rather, you will prefer to reach near this point. So limits will have so the limits also have the concept like this. So let's take a function to have let's have a function to have a concept of limits on them. If you have a function like f of x is equals to x cubed minus 1 divided by x minus 1, and I'll ask you to evaluate this function. We have already seen how you can evaluate the functions. So I will ask to evaluate this function at which value of x? At x equals to 1. What you will do? Let's say how we can evaluate. If I'll write f of 1 is equals to 1 minus 1 divided by 1 minus 1, what you will get? 0 divided by 0. This is what is this condition? This is the condition that is indeterminate or undefined in mathematics. In mathematics, the condition is defined as undefined when you have the 0 as in the numerator as well as in the denominator. So, in order to tackle such situations, we prefer not to put the value of x, that is equals to 1, in order to avoid such situation. So, we prefer to have a value that is close to x. Okay, so that is close to x, so here it means that is close to 1. So if I say if x is equals to 0.2, as I have to put the value close to 1, so I'll prefer to use the values less than 1. Like if x is equals to 0.2, then how the function will be, then I'll write, as the function was x cubed minus 1 divided by x minus 1, that will be equal to 0.2 whole cube minus 1 divided by 0.2 minus 1. What we will get? We will get 1.24. So this is a value that is acceptable. Now again, if I put the value of x as x is equals to 0.5, so I am increasing the values of x, then the function will be x cubed minus 1 divided by x minus 1 equals to 0.5 cube minus 1 divided by 0.5 minus 1 equals to 1.75. Okay, it is also acceptable. So if I'll put if x is equals to 0.9, then the function will be 0.9 whole cube minus 1 divided by 0.9 minus 1, and it will be equal to 2.71. Further, we will use the value close to x as x is equals to 0.95. Then what will be the value? 0.95 whole cube minus 1 divided by 0.95 minus 1 equals to 2.85. Another value I'll take as if x equals to 0.99. So keep in mind that I am not taking x is equals to 1, as I have already seen that at x is equals to 1 the function becomes undefined. Then we will have 0.99 whole cube minus 1 divided by 0.99 minus 1, that will be equal to 2.97. So that means as x gets close to 1, we get the f of the function, that is f of x, gets close to 3. So it means if x gets close to 1, as it is already seen above, then as a result f of x gets close to what? Gets close to 3, as it is clear from here. 2.71, 2.85, 2.97, it is increasing. So it means at x equals to 1, f of x is undefined, but at x equals to 0.99, f of x going closer to 3. So these are the 2 points important here that we have evaluated from the above. So it means we cannot take f of x equals to 3, we cannot take x equals to 1 here, and that means f of x is equals to 3. So limit is proposed in such a situation. So this is the basic concept of the limits, where we cannot reach the destination due to the undefined function, or we cannot take the value of x that will make the given function undefined, but we can take the values of x that is close to that values of value of x, like in this case the value that is close to 1, because that is not making the given function undefined. So the limit is proposed in such a situation. So I'll say that f of x will be 3 as x approaches 1. You can use this statement. Symbolically, how you can represent the limits, as we can say that limit lim, this is the word that you have to use, x approaches to 1, then you have the function f of x. This is the representation of the limits, and then you can replace the function value in a way limit x approaches to 1. The function was x cube minus 1 divided by x minus 1, and it is equals to 3. Means when you are moving towards when you are using the value less than 1 but not equal to 1, the given function is approaching towards the value of 3. As we have already seen that it was approaching to 3. So here is a very important statement that you need to understand. We cannot say value of x cube minus 1 divided by x minus 1 at x equals to 1, but we can say x cube minus 1 divided by x minus 1 is equals to 3 when x approaches 1. So there is a difference between these two statements. At the first one, we have said that we cannot say that the value of the given function at x is equals to 1. It means we cannot give a definite value of the given function at x is equals to 1. But we can say that the given function will give you with the 3 if you approach towards the 1. So there is a difference between x is equals to 1 and x approaches to 1. So x equals to 1 differs from x approaches to 1. In this way, the limits are differ because the x approaches to 1 and x equals to 1 can never be equal, as sometimes at x is equals to 1 the condition becomes undefined, in that we basically consider in mathematics. So we prefer to use the statement of x approaches 1 rather than x equals to 0, x is equals to 1. So here comes the concept of x approaches to 1, or the limits, where you get the undefined function. So this is all about the limits, where you have to use the limits and how they came into being and how they actually replace the actual value of x, and you have to use the approaching value of x rather than the actual value of x. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.